So we just got our hands on the very first used oil analysis for Valvoline's brand new Restore and Protect oil. And let me tell you, the lab report is in and it reads less like a clean bill of health and a lot more like the first chapter of a mystery novel. Seriously, we've got clues, we've got red herrings, and we have some numbers that are genuinely a bit worrying. Let's dive in and see what's going on. And that really is the big question here, isn't it? Is this new oil living up to all the hype, or is this lab report the first little warning sign of a silent threat to the engine? We're going to break down all the evidence, piece by piece, and see if we can figure it out. Okay, so first things first, let's get the basic facts of the case down. We're talking about a 2017 Honda Accord. It's got about 95,000 miles on it. The oil itself, this Restore and Protect, was run for 4,250 miles, but, and this is super important, that took place over 8 months. Now remember that 8-month number. Tuck it away, because it is going to be a key clue a little later on. All right, so let's crack open this lab report from Blackstone Labs. The very first thing that just jumps off the page and basically sets off an alarm bell was the iron reading. Now, as you know, iron in your oil means one thing. Something made of steel is wearing down inside your engine. And just look at this. The difference is, well, it's stark. The universal average for this kind of engine is somewhere around 11 parts per million. This sample, it came back at a whopping 33. We are talking 3 times the normal amount of iron. That is a major, major red flag. So where is it all coming from? Well, right now, we've got 2 main suspects. Suspect number 1 is a fuel additive that was used. It's got this stuff in it called ferrocene, which is basically an octane booster. When it burns, it can leave behind tiny iron particles that find their way into the oil, which could be making that reading artificially high. Then you've got suspect number 2, a known mechanical problem. There was a faulty timing chain tensioner that was causing a rattle on cold starts. And that rattle? Yeah, that's literally the sound of potential metal-on-metal wear, which would be shedding iron directly into the oil. But, just like in any good mystery, right when you think you've got your suspects all lined up, the plot thickens. Turns out, iron wasn't the only thing that looked a little off in this report. Yeah, 2 other elements really stood out. Manganese was also way too high. Blackstone Labs said, hey, this could also be from that fuel additive, or it could be a sign of wear in the valve guides. Not great. And then there's silicon, which was also pretty high. Now, that could be from some engine sealant breaking down, or, and this is probably more likely, it could just be junk from some bad quality gas that was used in the past. Now, before we all start to panic, it is so important to look at what's not wrong, because there is a ton of good news in here. This slide basically shows that the engine is fundamentally healthy where it really counts. Chromium, which tells you about piston ring wear, is at 0. Perfect. Copper, lead, and tin, all the big markers for bearing wear, also 0. This tells us the engine's rotating assembly is in fantastic shape. Plus, no coolant in the oil, so the head basket's good, and the low insolubles mean the oil filter is doing its job perfectly. So, while we have this iron mystery, this isn't an engine that's about to blow up. So, the wear metals are a total puzzle, a real mixed bag. But that leads us to the most important question of all. Forget where the metals came from for just a second. How is the oil itself holding up? Does it have any fight left in it to actually protect this engine? To answer that, we have to talk about a key metric called TBN, or total base number. The easiest way to think of this is like the oil's health bar. It's a measure of its reserve additives that are there specifically to neutralize all the nasty acids that build up during combustion. The higher the TBN, the more life and protective power the oil has left. Now, this oil started with a pretty healthy TBN of 6.7, right out of the bottle. After those 4,250 miles in 8 months, it's been knocked all the way down to just 2.8. You can see right here, nearly 60% of its protective ability is just gone. And a TBN of 2.8 is getting you really close to the line of what's considered effective. So here's the crucial part. You've got this battle happening inside the oil. Think of the total acid number, or TAN, as the attackers. And in this report, they're at a high 4.8. The total base number, our TBN, those are the defenders, and they are down to a measly 2.8. So when the attackers outnumber the defenders like this, your oil has basically lost the fight. It can no longer protect the engine from corrosive wear. And hey, remember that clue from the very beginning, the 8 months? Well, this is almost certainly why that acid level is so sky high. Oil doesn't just break down with miles, it breaks down with time. Oxidation just happens from sitting there, from heat cycles, and it eats away at that TBN, even if the car isn't going anywhere. And there's one last little wrench in the works we have to consider. Because this was the very first time using Restore and Protect, there was still some of the old oil left in the engine from the last change. You never get it all out, right? That leftover gunk absolutely could have contaminated this sample and skewed some of these really strange results. So, what's the plan? How do we solve this thing? Well, to get to the bottom of it, a clear plan is needed. First up, change the oil every 6 months maximum. We have to fight that time-based breakdown. Second, get the next analysis done way sooner, at just 2,000 miles, to get a much cleaner snapshot. And third, keep doing these analyses, one after another, so we can establish a real trend and finally figure out if the culprit is the oil, the additive, or the engine itself. So yeah, this first report has definitely left us with way more questions than answers. It's a fascinating mystery, and there are a few plausible suspects on the table. The only way we're ever going to solve it is with more data. So the real question now is, what will that next 2,000-mile report show us? Will we get a clean bill of health, or are we about to confirm a much more serious problem brewing inside this engine? I guess we'll find out.